The view of a rust-colored rocket carrying an orbiter on its back, spewing giant clouds of smoke and rushing to the sky on its fiery tail is iconic. But, considering the last Space Shuttle launch was back in 2011, is this the last we'll ever see of such a thing? What's next? Could an improved shuttle be made that takes off and lands like an airplane? Well, let's explore the possibilities. Use your imagination to draw two parallel horizontal lines. Now, connect these lines at any point you want in two different ways. With a vertical line that goes straight from the bottom line to the top one, and with a diagonal line. Which line is shorter? Of course, the vertical one. It's the shortest route to connect the top and bottom lines with each other. And that's also the most basic answer to our question. It's faster and easier to get into orbit by just going straight up from the ground. The bottom line is the Earth's surface. Our planet is a complex hodge-podge of all kinds of matter, which is combined into an impressive mass, almost 6 sextillion tons. That's like 6,000 billions of billions. Lots of zeros there, just like my middle school math scores. All that math basically works like a colossal magnet that, besides other significant feats, allows the Earth to maintain one thing we all know and love: the atmosphere. The top line is the limit of the Earth's atmosphere. Anything beyond that is the planetary orbit and outer space. But the atmosphere itself is also filled with matter. It's a combination of gas that has its own density. When a shuttle is launched, all the mass of this gas was constantly pushing on it, which caused friction, effectively slowing it down. Going through a vacuum is like cutting through the air, whereas getting through the atmosphere is like going through jelly. Ooh, grape or strawberry. It took a lot of energy and force to get through it, while being pulled back by that giant gravitational magnet called Earth. Airplanes don't struggle this much with getting through the atmosphere, because they use its density to lift up from the ground and maintain altitude. Two things help them with that: the thrust of their engines and the form of their wings. The wings of an airplane force the air in front of them to split into two streams. Naturally, these streams want to reunite behind the wing, but the shape of it makes the upper stream go faster. The faster the air goes, the less dense it becomes, and that means that the airstream that goes underneath the wing is denser than the upper one. This creates a gradual lift for the airplane. Basically, wings make it so that the airplane can glide on the air. But of course, that wouldn't be possible without a huge force pushing the airplane along. This is what thrust is for. Just to take off from the ground, an airplane needs to attain a huge speed. This speed varies enormously between different kinds of airplanes. 60 miles an hour for light planes, and about 150 miles per hour for airliners. And just to take off and climb to 10,000 feet, the Boeing 747 needs a little less than 3 tons of fuel. That may sound impressive, but let's look at that Space Shuttle. The first obvious things are the cute, tiny, stubby wings that wouldn't be of any use for a horizontal takeoff. But if one was built with more excessive wings, they wouldn't be of any use in the vacuum of space. It would also be hard to make them sturdy enough to make it through the launching process. The little wings of a space shuttle served only one purpose: to land the shuttle safely so it could be reused in future missions. They were just big enough to prevent the shuttle from spinning uncontrollably during the descent through the atmosphere and to glide it to the ground. It didn't utilize any engine operations during landing at all. The engines of the space shuttle were nothing like the engines of a plane. The airplane's engines needed air from the atmosphere to work. The shuttle's engines obviously didn't, since atmospheric air would have been hard to find in space. Instead, the shuttle used rocket engines. To show what rocket means here and how these engines work, just blow up a balloon and release it from your hand. It'll fly around until there's no air left inside, all the while being pushed in the opposite direction as the air coming out. To fly up, a rocket engine has to throw off enough thrust and burn the right amount of fuel to do the job. In fact, space shuttles needed so much fuel during their ascent to make enough thrust that they couldn't do it on its 3 engines alone. They needed 2 additional solid rocket boosters and a huge separate fuel tank that was jettisoned at the final stage of the launch. And a shuttle would only go into orbit if it had enough power. The power of a shuttle with 3 engines and 2 boosters is around 7.8 million pounds of thrust. To power up this much push, an external tank held around 1.6 million pounds of rocket fuel. And to keep the flight under control, those 3 engines had to be mind-numbingly complicated in structure. But would it be even possible to fly a shuttle into orbit if it was modified to use the atmosphere like planes? Well, unfortunately, the answer is no. It would take even more fuel to maintain the needed speed for the distance of a diagonal launching trajectory. The thing is, even if a plane climbs to the upper part of the atmosphere, the Earth still won't let it get away. To escape the atmosphere, any object that starts from the Earth would have to be fast enough to cross the point of so-called escape velocity. This velocity is needed to overpower the gravitational pull of the planet and let an object go into orbit. For our planet, this orbital speed is 17,500 miles per hour. It's obviously way faster than the speed of sound, and many, many times faster than the cruising speed of an airliner. Now, try to imagine an aircraft that goes this fast and how much fuel it would require. On top of that, it'd have to be sturdy enough to keep itself in one piece while doing so. The cost and complicated technology would just be unrealistic. The possibility that shuttles have become a thing of the past has caused scientists and engineers alike to try to find even better solutions for getting into orbit and beyond. One such idea proposes that in the future, people would be able to go to space on a huge space elevator. A space elevator is the concept of a huge tower that connects to a satellite at the top, which moves in line with the rotational movement of the Earth itself. The tower is supposed to be about 22,000 miles high and made of extremely durable material, carbon nanotubes. The platform inside the tower is planned to be set in motion via electromagnetic-powered vehicles. The trip from Earth to the satellite would take just 5 hours. This megastructure would allow for a cheaper and safer way of getting into space, but carbon nanotubes were proved not sturdy enough for building a tower this huge, so the search for an ideal material continues. Another project that uses a similar approach is called a SpaceTram. The structure needed to launch this project isn't as big, but still quite impressive. It's a vertical vacuum tunnel that pushes a magnetically levitated shuttle. It won't be slowed down by the air, and it'll be pushed and accelerated with an electromagnetic force through the tunnel. It'll then shoot into the skies at a speed close to escape velocity. The shuttle powered by this tunnel will weigh less because it won't need to carry a lot of fuel. No word yet on how human beings would survive such acceleration. Riders might look like pancakes upon arrival. If these ideas sound strange to you, and they do, then get ready for the last one. It's possible that people will use planes as a way of getting into orbit. No, I didn't lie to you previously. The plane won't go into space by itself. Instead, it'll be used as a launch platform. Even better, huh? For this purpose, a special aircraft will be made with an almost 400-foot wingspan and capable of climbing to an altitude of 35,000 feet. Small shuttles launched from this aircraft won't have to go through so much of the thick atmosphere, making it easier for them to get out from the gravitational pull of the Earth. Richard Branson is working on this technique right now with his Virgin Galactic program to take tourists to the edge of space. Sounds exciting. So, could airplanes replace space shuttles altogether? No, but that doesn't mean they won't help them become more effective in the future. Hey, if you learned something new today, then give the video a like and share it with a friend. And here are some other cool videos I think you'll enjoy. Just click to the left or right. And remember, stay on the bright side of life.